Alright, today we are going to go over another multi-step word problem, and let's just get right into it. So Jake has 1,500 cents to use for some new toys. He wants to buy a bouncy ball for 364 cents, a package of Pokemon cards for 186 cents, and 2 fidget spinners for 214 cents each. How much change should he get? So we need to figure out what the difference is between what he starts with, which is 1,500 cents, and what he spends, which is all of this added up. Now this one, it says he bought a bouncy ball for 364 cents, Pokemon cards for 186 cents, but he bought 2 fidget spinners for 214 cents. So that means that we actually have to add in 214 twice, right? 2 times we have to add this up. So what I'm going to do is I'm going to use the standard algorithm, and we can actually stack all of these numbers on top of each other. 186, 214, and I have to put in 214 twice because he bought 2 fidget spinners. Okay, so we are adding all of these up. So we have what he started with, 1,500. Now we have to find what he spent, which is this. Okay, so 4 plus 6 is 10, plus 4 plus 4 is 8, 10 plus 8 is 18. Carry the 1. 1 plus 6 is 7, 7 plus 8 is 15, plus 2 is 17. 1 plus 3 is 4, plus 1 is 5, 2 plus 2 is 4, so that is 5 plus 4, 978. And I do just want to show you guys that if, let's just say there was another number in this column, it was a 3, and this is 18, well, if we added 3 to that, it would be 21, and in that case, we would actually put the 1 down, right? And then we would carry the 2. And I just wanted to mention that if you're adding more than 2 numbers, you can actually end up carrying whatever is in the tens column of what you've added up. So in that case, it would be a 2. It could even be a 3 or a 4, depending on how many numbers you're adding up. So I just wanted to mention you can carry a number that's more than 1. For our problem, that's not relevant, but it is relevant, just so that you guys understand that. So we're at 978. He has spent 978 cents, but it doesn't ask how much money has he spent. It says how much change should he get, which is actually, if he has 1,500 cents and he spends 978 cents, we're looking for the difference between 1,500 and 978. So that means we need to subtract. Once again, I'm going to do the standard algorithm, 1,500 minus 978. Obviously line up the place value, and now we can subtract. 0 minus 8, we cannot do that. Typically, I would borrow from this number, but it's also a 0. So how I like to think about it is I go over to the next one, and now I'm borrowing from 50. So then the 50 becomes 49, and this becomes a 10. 10 minus 8 is 2. 9 minus 7 is also 2. 4 minus 9, I can't do that, I have to borrow. This becomes a 0. This becomes a 14. 14 minus 9 is 522. So there's 5, so it's 522 cents. That's how much change he should get. And I know that quite a few kids would probably get this number, or even get the number without putting in the second 214, just adding these three numbers up and then just putting that as the answer. And that's not the answer. You can't just do one step of a word problem and then just be like, well, I did some math, here's the answer. You have to always make sure when you actually answer, you're like, what is this number representing? And in this case, it's what he spent. But that's not what they're asking. It's saying, how much change should he get? So you need to make sure that the number that you are putting as your answer is actually asking or is actually answering the question that they're asking. Because if it's not answering the question that they're asking, even if you did all the math right, it is not the right answer.